Hello friends, welcome back to the lecture series of S prompts, and today we will be discussing on paired sample t-test. This paired sample t-test is also called as a dependent sample t-test, which means there will be only one sample which is involved in the test. The one thing which we need to remember is that the sample parameter which is included in the study is measured twice, which will give us a pair of data set. Before and after type of study is conducted using paired sample t-test. It simply means that the same sample population data measured before the treatment and after the treatment, and then the difference of effect of treatment will be measured using this type of study. Suppose a researcher wanted to see impact of training program on performance of employees. So the data which is related to performance can be measured before the training program, and then the same employees will be given a training program, and then again their performance will be measured on similar parameters, and any difference on improvement of performance can be noted, and then a paired t-test can be performed. Similarly, a pharmaceutical company can see the effect of old drug and new drug in the same set of patients, and their differences in results can be noted. Another example could be studying the improvement in results of students before and after the subject lectures. Few more such examples which can be mentioned here, okay, that can be analyzed using the pair t-test is a doctor who want to compare the blood pressure of his patients before and after giving a new antihypertensive drug. Second, same group of patients can be treated with two different medicines and their results can be compared. Sale of products before and after advertisement, or increase or decrease in price or packaging of the product, etc. So these are the different examples which can be tested with the help of this paired t-test. There are certain assumptions which are related to this paired t-test. First is the dependent variable included in the study must be continuous variables. For example, performance, sales of product, effect of drug, etc. The data collected from the same sample is independent of each other, as observations are collected before and after, and both the data is separately measured. The differences in the data set is because of the treatment included in the study. The dependent variable should be approximately normally distributed, and the dependent variable should not contain any outliers, means the data should be normally distributed on either side of the mean, and the data should not be far away from the mean as well from other data set. If you look at this graph, the majority of data is ranging between +2 to -2. Hence, we can say this part of data is normally distributed, while few of the data is far away from the rest of the data, even away from -4 value. Such data is called as a outliers data, and such data is not expected into a paired t-test. The paired t-test requirements are: the paired sample t-test requires the sample data to be numeric and continuous, as we have discussed earlier, as it is based on the normal distribution. Second, continuous data can take on any value within a range, such as income, height, weight, etc. And the opposite of continuous data is discrete data, which can only take on a few values like low, medium, high, etc. How to perform a paired t-test? Let's understand with one example. Suppose a doctor is comparing blood sugar levels of his patients before and after giving a new anti-diabetic drug introduced into the market. The blood sugar values of patients before and after giving the new anti-diabetic drugs are given in the table as follows. Before we go further for doing an actual calculations, let's first formulate the null hypothesis and alternative hypothesis. Since here we are comparing the effect of new drug on blood sugar level before and after the treatment, hence our hypothetical statement should include difference of effects before and after treatment with new drugs on blood sugar level. After giving the treatment with new antidiabetic drug, and if there is no change in the blood sugar level after the treatment, that is the values of blood sugar level before and after treatment is same, then the difference value of before and after will be 0. Say for example, the blood sugar level before the treatment is 150 and after the treatment is also 150, then the difference value of 150 minus 150 will be 0. So let's formulate one-tailed and two-tailed hypothesis. The null hypothesis can state that the mean difference of treatment in blood sugar level is equal to 0. That is, the blood sugar level before and after treatment is equal, or we can put it in another way, there is no significant difference in blood sugar level before and after the treatment with new antidiabetic drug. That's why we can mention as H0 is mu1 is equal to mu2, or mu1 minus mu2 is equal to 0. So this is how we can frame our null hypothesis. Now we can formulate a two-tailed alternative hypothesis statement as H1 is the mean difference of treatment in blood sugar level before and after treatment is not equal to 0. Or we can put it in another ways, there is a significant difference in blood sugar level before and after the treatment with new antidiabetic drug. We can formulate a upper tailed alternative statement also, such as H1 is the mean difference of treatment is greater than 0, okay, or with a lower tailed alternative statement can be formulated as the mean difference of treatment is lesser than 0. So in this way we can formulate the null as well as alternative two-tailed and one-tailed hypothesis. The same in words can be mentioned as given here. This is what we have just discussed. The formula for T statistics is summation of D divided by under root of n summation of D square minus summation of D bracket square divided by n minus 1. Now here we need to know what is capital D stands for. So n is the sample size which is 10 that is given to us. D is the difference of values before and after the treatment, and df is the degree of freedom which is n minus 1, that is 10 minus 1 is equal to 9. Since in hypothetical statements we are looking for the difference in before and after treatment, hence we first need to calculate the difference between blood sugar level before and after the treatment. Okay, so this is the values which are given to us. The values of difference we can write down in the next row, where we will subtract before values from after values. So when we will minus 160 from 125, the value that I will get is the capital D value, that is minus 35, and for similarly other numbers I can get the values and it is as written in the table of capital D. We will have to also calculate the square values of this difference values. That means the square of minus 35, square of plus 2, square of minus 52, and so on. So the squared values of all these difference values will be written in the lower column. So now you can see we have got D values and we also have got D square values. But in the formula we need to have summation of D and summation of D square. So what we will do, we will add the difference D values and we will also add all the D square values separately. So when we will do summation of all the d values, we will get summation of d is equal to minus 280, and summation of d square is 12,502. Let's put all these values which is obtained into the paired t-test formula as follows. So we have got summation of d, and we have also got summation of d square. The value of n is known to us, which is 10. So we'll put all these values one by one. So first we will put summation of d here. So summation of d value is minus 280 divided by under root of n is 10 multiplied by summation of ed square, which is 12,502. We will close this bracket minus in the bracket minus 280 and bracket square divided by n minus 1, that is 10 minus 1. So in the next step, what we will do, we will keep the numerator value minus 280 as it is, and then we will multiply 12,502 by 10, and we will get 1,25,020 minus square of minus 280 will be 78,400. Okay, and divided by 10 minus 1 is equal to 9. So now we have written all the values in this graph. In the next step, what we will do, we will subtract 78,400 from 1,25,020. The obtained difference value, we will divide it by 9. Okay, so that what remains with us is minus 280 divided by under root of 5180. Okay, so in the next step, what we will do, we will take the value of square root of 5180, and we will write down it as minus 280 divided by 71.97. This 71.97 is the value obtained after doing a square root of 5180, and when we divide this minus 280 by this 71.97, we will get t statistics value, that is minus 3.89. Now this obtained t statistics value, that is minus 3.89, we have to compare with the critical value, that is the value which is given into t statistical table. Since we have performed a two-tailed test, our significance value will become alpha divided by 2. That is, a 0.05 divided by 2 is equal to 0.025. Now 0.025 will become our alpha, that is significance value, and our degree of freedom is 10 minus 1 is equal to 9. Right? So this is the statistical table of t. So at degree of freedom 9 and at significance value 0.025, the critical value in this table is 2.262. Now what we have got till now is t statistical value as minus 3.89, degree of freedom 10 minus 1 is equal to 9, significance value of two-tailed test alpha is equal to 0.025, and the t critical value is minus 2.262. The decision rule says that if the calculated t value is greater than the table value, then we should reject the null hypothesis. And in the given problem, the calculated value, that is t statistics, is minus 3.89, which is greater than the critical value minus 2.262. Hence, we will reject the null hypothesis, and now we can conclude that the mean difference in blood sugar level before and after treatment is lesser than 0. Means the drug has effectively reduced the blood sugar level after the treatment. The same we can find from the normal distribution curve. Since the calculated value is a negative value which is falling on the left hand side of the curve, the critical value is minus 2.262 and the calculated value is greater than 2.262, falling in null hypothesis rejection zone. Hence, we can reject the null hypothesis and accept the lower tailed alternative hypothesis. That's all from my end, guys. Hope this video is informative to you. If you like this video, share this video with your friends. Press the like button and you can also write comments to me. All the best. Do well. Thank you.